In this video, we'll be solving a question from logarithmic inequality. The number of integral solutions of x, which means how many integer values of x satisfies this inequality, that is log of x minus 7 divided by 2x minus 3 the whole square divided by x plus 7 by the whole to the base x plus 7 by 2 greater than or equal to 0. Now, the thing is, whenever you get a logarithmic question, that is log x to the base a, we will be thinking about two conditions, that is the base is greater than 0 but less than 1, and another possibility is base is greater than 1. When base is greater than 1, our graph will be an increasing graph, and when base is less than 1, our graph will be always a less than a decreasing graph. Now we don't need to think about this possibility, that is whether this quantity, that is the base, here the base is this value, right? This value is positive or negative. Therefore we'll be converting in terms of another base. We will be converting the base in terms of e. Therefore we can do it directly with this logic, that is when a is greater than 0, greater than 1, we can use the regular graph, right? Therefore first I will be writing this in the form of what is log a to the base b. You can write it as log a to the base c divided by log b to the base c. If nothing mentioned, the base will be e. Therefore this will be equal to log of x minus 7 divided by 2x minus 3 the whole square greater than or equal to 0 the whole divided by log of x plus 7 by 2, that is the base is e. If nothing mentioned, base is e. Now there are two possibilities. When you divide a positive number divided by positive number, you will get a positive number which is greater than 0. Again, when you divide a negative number with another negative number, this will be greater than or equal to 0, because the signs will be cancelling. So that's a condition. Therefore first condition we are taking both the values are positive, that is both are positive. We can write it as log of, that is log of x minus 7 divided by 2x minus 3 the whole square is greater than 0 or equal to 0. We can take greater than or equal to 0. Now this condition can't be 0, it should be greater than 0, because it's the denominator, it will be positive only, no, it can't become 0. Therefore it will be log of x plus 7 by 2 will be greater than 0. That's our first case, that is both are positive, numerator and denominator are positive. Now for getting the value positive, first we can take this is positive. When the base is by default it is e, log 1 is 0, therefore this value should be greater than 1, that is x plus 7 by 2 should be greater than 1, because the graph is like this. When at x equal to 1, the y value is 0. When you give a slightly bigger value than of x, then the value of log 1 becomes 0. Therefore log 0 is 1, sorry, log 1 is 0, log 0 doesn't exist, log 1 is 0. Therefore if you put a value greater than 1, this will be greater than 0. That's the logic. Now we will be getting one of the conclusion that x greater than, when you bring it here, it will be 1 minus 7 by 2, which will become minus 5 by 2, that is x greater than minus 2.5. that's the one conclusion we will get from the denominator. Now the numerator should be greater than 0, right? That means greater than or equal to 0. Therefore this value will become x minus 7 divided by 2x minus 3 the whole square will be greater than or equal to 1, because here there is 0, there is equalities there, that means its value can become 1. Now we will be comparing only the absolute value, because we are taking the square of the thing. We only need the magnitude of this thing. This, whenever the magnitude of this inside term is greater than 1, the square will become automatically greater than 1, it will become positive. Therefore we just need to compare the magnitude only. Therefore we are just comparing the magnitude. This magnitude is greater than 1. Now when you take square root, magnitude of x minus 7 divided by 2x minus 3 should be greater than or equal to 1. Therefore x minus 7 mod x minus 7 divided by 2x minus 3 should be greater than or equal to 1. From there, this conclusion, x minus 7 should be greater than or equal to 2x minus 3 the whole mod, and provided that 2x minus 3 not equal to 0, that is 2x minus 3 not equal to 0, that is x shouldn't become 3 by 2, because denominator can't be 0, but x can become 7 is 0. Also there is one more thing, x can't become 7. The reason is when x becomes 7 means when x equal to 7 means we are literally finding log 0 that doesn't exist. That also we need to be careful. Here we will be using the graph. We will be using the graph. Now we can draw the graph of y equal to mod x. Y equal to mod x mod of x minus 7 graph. So the thing is the critical point of this graph is x equal to 7. So at x equal to 7 the graph will be going like this. Now when x equal to 1.5, x equal to minus 1.5 is the critical point, that is 2x minus 3 equal to 0, x equal to 3 by 2 which is equal to 1.5, that is the critical point of this graph. Now origin is already here. This graph has more slope, which means this graph will be a steeper graph than this one. This graph will be a steeper one, somehow like this. Now we need to find the point of intersection of these two graphs, right? Now in this region, this graph, that is this graph is mod of x minus 7 and this graph is mod of 2x minus 3. Now this graph will be positive over here and this graph will be negative over here. Therefore we will be equating for finding this point. At this point this is positive, that is modulus of a positive number is the number itself, and this value is negative because it is in this side of the graph. It will be equal to 7 minus x. Now when you solve this one, this x will be coming here, 3x equal to, this will be coming here, it will be 10, x equal to 10 by 3. That is approximately this point is 3.33 approximate. Now this value we need to find. In this case both the graphs are negative, that is 3 minus 2x, negative of this equal to negative of this, that will be 7 minus x. Now when you bring this value over here and this over here, minus 4 equal to x, that means this point is minus 4, x equal to minus 4. Now we will be solving with our condition. Now what was our condition? Mod of 7 minus x is greater. So 7 minus x is greater means 7 minus x, that is this graph of 7 minus x is above in this region, which means x can be a value from minus 4 less than x less than 3.3. Since there is equality sign over here, we can directly put equality sign here. And there is one more thing, the x value can't become 1.5. What will happen when x equal to 1.5? This value becomes 0. So in denominator 0 is not possible. Since we are only considering the integral value, leave that topic, because or you can write it as minus set to 1.5. We can eliminate that point. It's not necessary. Now the thing is, we only consider the integral values. Already it's clear that x is greater than minus 2.5. It's already there, which means x value will be from minus 2.5 less than x less than 3.3, which can be equal to 3.3 because here equality is there, minus set 1.5. Now what are the integral values in this region? It will be minus 2, minus 1, 0, 1, 2 and 3 respectively. There are 6 possible values. Now there is another condition. We already telling one more condition, that is both can be negative. Is it possible or not? In that sense, this value is negative, that is log of 7 minus x minus 7 divided by 2x minus 3, which is negative. This one is negative, and similarly this value is also negative, that is log of x plus 7 by 2 is negative. Both are negative. Then negative divided by negative will become follow the same inequality, right? So this condition we need to check. For this condition exist, first of all this value is negative. Before that there is one thing. Inside the logarithm we can only give positive values, right? That means if it is negative means, that is log a is negative means the a value will be from 0 less than a less than 1. It should be in between 1. Therefore we can start writing with x plus 7 by 2. This value should be less than 1, but it should be greater than 0. Now when you subtract with 7 by 2, that is 7 by 2 minus 7 by 2 less than x less than, this will be minus 5 by 2. That means from here minus 3.5 less than x less than minus 2.5. This is our range. Now in this range minus 3.5. So minus 3.5 is somewhere here. Minus 3.5 will be somewhere here. That will be in between the 0 and minus 1.5. And another region will be 2.5. 2.45 is somewhere here before 3.3, right? So this region. In this region, 3.5 minus 3.5 to minus 2.5. In this region, if you closely observe, the x minus 7, mod of x minus 7 graph is greater than, that graph lies above 2x minus 3 graph, mod of 2x minus 3 graph. That means x minus 7 divided by 2x minus 3 mod is greater than 1. That is x minus 7 divided by mod of x minus mod of x minus 7 divided by 2x minus 3. Already the numerator had a square over here. This value is greater than 1. Now the square of this value will be greater than or equal to 1. Therefore, this can be this value. The value inside this is greater than or equal to 1. Greater than or equal to 1. If it is bigger value, this logarithm value will be positive in that region, because the numerator is always greater than the denominator in this region, that is from minus 3.5 to minus 2.5. Therefore, this condition will be completely eliminated. This condition, we can't take this condition, both will be negative simultaneously. Therefore, our final answer will be how many solutions? Our number of integral solution will be 6. 6 will be the final answer.